Welcome to the Explainer. So you're prepping for your Solutions Architect exam and you know storage can be a real beast. Today, we're going to tame one of its most powerful and, let's be honest, often misunderstood services, Amazon's Elastic File System, or as we all know it, EFS. All right, let's get our architect hats on. We're going to start with the why, the basic problem EFS was built to solve. Then we'll dive deep into the 5 key areas you absolutely need to nail for the exam, and frankly, for building killer solutions in the real world. How you pay for it, how to make it go fast, how you lock it down tight, how you keep its data safe, and how it plays nicely with other services.
So first things first, before we get into all the bells and whistles of the service itself, we really need to understand the core problem it was designed to fix. And trust me, this is a classic scenario you're going to see over and over again in system design.
Just imagine this for a second. You've got a whole fleet of web servers, and every single one needs to access the exact same set of images or config files. Or what if you have a big cluster of data processing instances that all need a common scratch space? You can't just slap an EBS volume on there, right? Because that's locked to just one instance. And S3, well, that's object storage, a totally different animal. What you really need is a true, scalable, shared file system that everyone can talk to all at once. This slide just nails it. It perfectly shows you where EFS fits in the whole AWS storage universe. Think of it like this. EBS is your private garage. It's attached to your house, and it's just for your one car, or in this case, your one EC2 instance. S3 is kind of like a giant self-storage facility. You can dump pretty much anything there, but it's not exactly easy to get to. But EFS? EFS is the shared company parking lot. It is built from the ground up for thousands of cars or instances to just pull right in and access everything they need all at the same time. Okay, so here's the big takeaway for this first part. EFS is Amazon's purpose-built, cloud-native solution for that whole shared file access problem. The key words here are serverless, meaning you're not managing or patching any file servers, and elastic, because it just grows and shrinks automatically with your data. And super important, it speaks NFS, which is the standard, time-tested language for network file sharing in the Linux world. Okay, now that we know what it is, let's talk about the cost. Because for the exam, and definitely for your career, you have to get a handle on the pricing model. It's not optional. You've got to know how to build solutions that don't break the bank. And honestly, this is one of those areas where it is so easy to make some really expensive mistakes.
And this quote right here, it absolutely hits the nail on the head. You look at it and it seems super simple. You just pay for the gigabytes you store. But the reality is, your final bill can get a lot bigger because of a bunch of other factors. So let's pull back the curtain and see what's really going on.
So the first and most obvious way to save money is by picking the right storage class. For your hot data, the stuff that's getting hit all the time, you'll use EFS Standard. But for data that gets cold over time, you can set up Lifecycle Policies to automatically push it down to infrequent access or even the super cheap archive tier. Just doing that can slash your storage costs by more than 90%. And you'll also see that one zone option there, which is a different kind of cost-saving trade-off we'll get to in a minute.
But this is the stuff that gets you on the tricky exam questions. You have to know about these other costs. If you need more performance than the default mode offers, you're going to pay for provisioned throughput. If your EC2 instances are in a different availability zone than your data, boom, you get hit with cross-AZ data transfer fees. And remember those cheaper infrequent access and archive tiers? Well, you get charged a small access fee every time you read data from them. Getting these details down is what separates a good architect from a truly great one.
All right, let's switch gears and talk about performance. It's not enough to just store the files, right? You need to get to them, and fast. Choosing the right settings and even how you design your application is absolutely critical to getting the kind of speed your workload really needs.
So you've got a big choice to make here when it comes to performance. Elastic or provisioned throughput. Elastic is the default, and it's awesome for spiky, unpredictable workloads. It just scales up and down for you automatically, and you pay for what you use. Provisioned, on the other hand, is for when you know you need a certain amount of muscle all the time. You're basically reserving that bandwidth, and you pay a fixed rate for that guaranteed performance. It can actually be cheaper if you have really high constant traffic.
Now, this is a huge performance tip, and it's a core concept for pretty much any distributed system. EFS loves parallelism. You have to remember, under the hood, EFS isn't just one server, it's this huge distributed system. So by hitting it with lots of threads or clients at the same time, you're lighting up more of that underlying infrastructure. As you can see in this graph, the throughput scales almost perfectly as you add more parallel threads. A single-threaded app is just never going to unlock the full power of EFS.
And check this out. This slide shows another really cool performance trick: bundling your files. Think about it. Every single time your app opens a file, there's a tiny bit of network latency. Now, if you're doing that for thousands of tiny little files, that latency adds up fast. But if you bundle them all into a single archive, like a zip file, you do one open, read everything you need in one go, and then one close. The performance boost can be incredible. We're talking more than 10 times the throughput in some cases.
So to wrap up performance, let's just quickly recap the best practices you need to burn into your brain. First, pick the right throughput mode for your workload: elastic for bursty, provision for steady. Second, trust the defaults on things like mount options unless you have a really good reason not to. And finally, for those tricky small file workloads, think parallel, and maybe even bundle them up. These are the tricks that'll make your EFS applications fly. All right, next up is security, and this is totally non-negotiable. EFS is built on the NFS protocol, which has its own traditional security model. But, this is AWS we're talking about, so, of course, they've wrapped it in multiple layers of modern, cloud-native security controls. So traditionally, NFS works on what I call a trust-the-client model. The client connects and just says, hey, I'm user ID 5001, and the server's like, okay, cool. This works, but it puts all the responsibility on you to manage user IDs perfectly across every single client. EFS access points completely flip this around. They let you enforce a user identity on the EFS side. So it doesn't matter who's connecting, if they use that access point, they get mapped to the specific user and group that you define. And you can see right here just how simple it is to set up. When you create an access point, you literally just specify the exact POSIX user ID and group ID you want all connections to use. You can even define a root directory, which basically puts the connecting application in its own little sandbox inside the file system. This is a huge step up for security. For the exam, you need to know these 3 layers of security cold. First, at the very top, you have IAM policies. These control who can do administrative stuff, like who has permission to create or delete the file system itself. Then at the network level, you have security groups, which are basically your firewall. And you have to remember this. You must allow inbound traffic on TCP port 2049, the standard NFS port. And finally, at the application level, use EFS access points to control what a connected app can actually do with the files. Okay, last but not least, let's talk about protecting your data and how EFS plugs into the rest of the AWS world. I mean, a great architect is always thinking about resilience, disaster recovery, and how all of these services can work together to create something amazing.
When you create a file system, EFS gives you a really important choice. The default is regional storage. This is super highly available because, behind the scenes, your data is automatically copied across multiple availability zones. But if your workload is less critical, or maybe you handle replication yourself, you can choose one-zone storage. You get the same insane durability, but because it's only in one AZ, the availability is a little lower. So what's the trade-off? You get a nearly 50% price cut on your storage cost.
The real magic of EFS happens when you see how it plugs into everything else on AWS. You can use AWS Backup for totally centralized automated backups. For disaster recovery, you can use EFS replication to keep a copy in another region. And one of the biggest game changers is the integration with AWS Lambda. For the first time, this gives your serverless functions access to a real, persistent, shared file system. It's a huge deal.
So let's wrap this all up. EFS is an incredibly powerful and flexible service for shared file storage in the cloud. It solves a really common problem that architects face all the time. But to really use it well and to absolutely crush that exam, you can't just know the basics. You have to master the little details of its cost, performance, and security models to build solutions that aren't just working, but are truly great.
As you keep studying, I really want you to keep this question in your back pocket. Because this balancing act, juggling features, performance, security, and costs, it's not just some random topic for an exam. It is the absolute heart of what a great solutions architect does, day in and day out. Thanks for joining me.